a todos.
Bom dia.
É.
Então, nós estamos esperando a Karen ainda, ela tá com Covid.
Ah, é?
Então,
Coitada.
ela tá arrumando lá os últimos detalhes, parece que ela tá tossindo muito e tá incomodada tá preparada em incomodar, enfim, não nos preocupemos que ela tá chegando.
Imagina.
Lá são 7h30 da manhã, né, no Canadá. Então...
Ela entrou aí.
Ela entrou? Hi, Karen.
Hi, can you hear me okay?
Yeah? Open your camera so that we can see you.
No, that's what I'm trying to do. I don't know what's going on. Sorry. Should be now.
Okay.
Hi,
Hi,
Karen.
everyone. Hi there.
Hi.
Sorry for the delay. I'm sick with COVID, and it's I don't know. It's getting a bit better, but now it's not. Sorry about that.
You look good. You're not looking sick. So.
No. Very beautiful.
You're too nice. Nice to see you again, Max.
We miss you here in Florianopolis, Karen.
Oh, I had such a beautiful time when I was there. It's like one of my happiest memories.
For us too.
Say hi to Doris for me, please.
Okay.
Karen, I think you got the link from the YouTube. Did you?
No.
Because
No,
we could not.
I sent to everyone.
No, Michel sent to your students.
Yes.
Because we did not. I don't know if some of you, any of you, know how to allow the people to come to the meeting without having to accept them on Teams. Because after Michel starts, if someone tries to get into the meeting, Michel would have to go there and say yes, and he can stop the presentation to do that.
Right.
So I'm just saying that it's better if they go to the YouTube link, but Michel sent them the YouTube.
Yes.
Okay,
link,
they weren't
so
sure. Okay, so I'll tell them to go to the YouTube link.
Yeah, so tell them we are sorry if something happens.
Yeah.
It's just that we can't stop the presentation to allow them in.
Okay.
If they are here,
It's working.
it's working. The link on YouTube is working. So.
Okay.
Okay, so we can start, right?
Yes.
And sorry, everyone. We have to speak English today.
Yes.
Thank you. And Lillian, congratulations to you on your baby.
Okay.
Thanks a lot. Yes, it's a very new life for me. Yes.
We will start in Portuguese, then I will shift to English, okay? Because then we're gonna cut the beginning of the presentation to have it online on YouTube. So, ok. Bom dia a todos. Estamos aqui. Deixa eu entrar um. It's just that someone is interested.
Yes.
It's Nicholas Martin.
One of the Karen's students.
Ok. Bom, então nós vamos cortar.
Não vai ter.
Tá? Bom dia a todos. Estamos aqui hoje para a defesa de doutorado do aluno Michel Rodrigo das Chagas Alves. Essa é a tese número 416 do nosso programa de pós-graduação em engenharia elétrica. O trabalho do Michel foi feito, foi orientado em parceria por mim, Patrícia Nascimento Pena, aqui do Departamento de Engenharia Eletrônica da UFMG, e a professora Karen Rudy, da Electrical and Computer Engineering Department na Queen's University, no Canadá. Eu agradeço a participação da banca, né, que aceitou estar conosco aqui de manhã, cedinho. Essa banca é composta pelo professor Dr. Max Ering de Queiroz, do Departamento de Automação e Sistemas, da UFSC. A professora Lilian Kawakami Carvalho, professora do Departamento de Engenharia Elétrica da UFRJ. O professor Ricardo Hiroshi Caldeira Takahata, professor do Departamento de Matemática da UFMG, e o professor Carlos Andrei Maia, professor do Departamento de Engenharia Elétrica da UFMG. Então, a nossa banca vai ter 3 fases, né? A gente, primeiro, o Michel vai fazer uma apresentação, onde ele expõe os resultados da tese dele. Em seguida, a banca vai arguir o Michel, e, em seguida, vamos para a deliberação em relação à aprovação ou não do Michel. Okay, so we're going to start now. Michel is going to have about 50 minutes to give his presentation phase where we did, and I have to thank you all for coming. We'll ask questions that Michel earned, if he will earn the title of a PhD. And then we're going to deliberate and decide if Michel passed. Okay.
I would like to start by you now to me to participate in this meeting. Thank you for your presence here. So I'm going to say to present my work that is impacting the control of discrete-event systems subject to cyber attack. My advisor, Professor Patricia, and Professor Karen. In my talk, I will do a brief introduction to the subject. I will show a little literature review on the subject. I will present some concepts on base concepts on DS. Then I will start to present my results. The first one is related for the new test for the P-observability for an attack set property. Then I will present my latest results that are related to persistent attackers. And then at the end, I'm going to present some results on the implementation of the security testbed. And finally, I will present some conclusions. So in a cyber physical systems that are also known as CPS, we have an integration of physical processes that are controlled by the digital world. And in this kind of systems, the devices don't need to be in the same network. They don't need to be in a local network. The applications are many, and the CPS are one of the key features of the fourth industrial revolution. As the end control system, one of the elemental testing is to read information from the sensors and to send information from hormones to actuators. And like I said, devices are now those necessarily to be the same network, so they can't be actually for a larger network, so they need to extend information. We should be these large networks. And the problem is that devices and networks have vulnerabilities. And what happens is that violation layer can take advantage of the vulnerabilities. They can stop the production process. They can make increase our drive and ask for ransom. They can cause physical damage in the process, and there are many goals they can accomplish. So the nature of cyber attack, the real case of cyber attacks presents a case where the malicious agents layer, where the communication is being exchanged, the application control layer, where we have the control, and the execution layer, that's the layer where the sensors and actuators are. But when we look at the system, most of the research security will consider the attack sensor channel and the actuator channel or both channels. But what we actually see that basically most of the research actually focus on the first layer here, over here, on the data transmission layer. And so that's a problem because the real case of cyber attacks, we have attacks on the execution layer and the application layer. And when we try to apply the same results, theoretical results, or when we consider attacks on the communication channels, they don't apply directly. You have to do something. And so that's one of when we saw this with the development of thesis, we tried to propose something that would get a little bit smaller. So the contributions of this thesis are the development of a new test and that interpretation for the P-observability for an attack set property. This property is related to ability to a supervisor to be robust to attacks, even that's it. The ability of a supervisor to be robust to attacks. I'll talk about it more later. Also, we contribute with the development of an attack model that describes attacks in the network interface of the devices, instead of considering attacks on the communication channels. We will also introduce a new class of attacker called persistent attacker. We also propose a development technique, a design technique for these persistent attackers. We also proposed a testbed that allows us to test the attack influence strategies. The literature on cybersecurity has many surveys and covers discrete-event system and continuous time system as well. And there are works that focus on describing real cases of cyber attacks. And like I said before, what you can see that mostly of the research on cybersecurity context of control system focus on the attacks on the communication channel. And what happens is that attacks actually happen in the communication channel. That's not a problem. The problem is that there are other kinds of attacks that are not covered by the literature on on script. To work propose something that would fill this gap. In the context of DS, we have approach consider attacks in sensor channel, acquaintance channel, both channels. And they also propose different attack strategies to deal with security. One that they can be classified in the, for example, they also propose attack design of attackers, and they claim that if we study an attack, we will get some knowledge about it, then it will be easier to defend against such attackers. So I'm going to talk a little bit I'm going to talk about a little about supervisory control, because it's one of the main concepts we will use in this thesis. So we consider the framework, the classical framework of supervisory control that proposed by Hamad and Wanan, and where we have a plant that's modeled as an automaton. This plant has a generated language and a marked language. And also this plant can be, the event set of the plant can be partitioned in controlled events that are the events that we can control, that we can say when they happen, and there are uncontrolled events that are the events that we cannot control. So we cannot prevent them from happening. We normally specify the desired behavior for the system as a desired language case. And the supervisor will obtain such behavior in the system by disabling controlled events. But the condition for the desired language to have is that it must be controllable. And the language is controllable when the expression here holds. We cannot control them. So they happen when they need to happen. we cannot see all the events that happen in the plants. We say that some of these events cannot be seen. So basically, the natural projection we erase from this string as some of these events. And an additional condition for the desired language to have is that it now has to be also observable. And a language is observable if basically if two strings that have the same observation, that generate the same observation, they should require the same control action. That have the same observation is each pair of internal P is also a pair in the second relation here that is a relation of pairs of strings that don't require different control actions. So if, like I said, if we get two strings have the same observation, they don't need to require different control actions because you cannot decide which one actually happens. So now I will start by presenting my first result of this thesis. It's related to the P-observability for an attack set, and we consider the attack model proposed by our KK and collaborators in 2019, where we have a supervisor control under partial observation. We have an attacker that can insert or erase events from the communication channel from client to supervisor. The attack can act on a subset of the alphabets of the events. This subset is called the set of vulnerable events. And actually, instead of only one attacker, we consider that there are multiple attackers. Each attacker can act on a different subset of the vulnerable events. But what happens actually is that they don't. Although we consider that there are many attackers, only one is acting, and we don't know which one. So when we are defending against this kind of attack, we have to consider the possibility of all, taking into account all attackers. The conditions for the desired language to have are controllability and P-observability for an attack set. And what is this property? This property is related to the ability to supervise that is always able to distinguish between strings that will require different control actions, considering the act of the attacker. And the authors of this work, based on use the attack model, propose a test which consists on checking if the language is observable for every pair, consider every pair of attackers in the attack set. So what we did here is to improve the result was to propose a new test of this property that instead of considering when doing multiple tests of the classical observability, we actually we check for the property, the observability for an attack set itself. And this test can be done in a single run. But to accomplish it, to make should be possible to do this test, we need to define some relations, introduce some definitions that allow us to model the attack, and then at the end we would do the test. So the first definition that we introduced is a definition that it's called instinctually state with respect to attacker or an attacker A. And because of the action of the attacker, what happens is that they use outcome to represent the desired language. Okay. And because of the action of the attacker, some of the states of this outcome are undistinguishable. For example, in here we have the set of vulnerable events are A, B, C, and D. And we have an attack set with two attackers. The first one acts on event A. And because of the action of the first attacker, event states 0 and 1 are undistinguishable. Let's say, for example, if we observe nothing at the initial state, we don't know if we are actually at state 0 or 1, because event A could have happened, but the attacker erased. Or we observed A, we don't know, we still don't know if we are state 0 or 1, because if nothing happens, but the attacker inserts event A, so we see event A, but the system, you know, that this outcome will still be at state 0. So because of the action, the possibility of the attacker to insert or erase events, it makes some of the states indistinguishable. Then we try to capture this by doing a relation of pairs of states that are indistinguishable because of the action of the attacker. And in this example here, we have the pair 0 and 1 is indistinguishable because of the action of the first attacker, and then the 1 and 2, 2 and 4 are because of the action of the second attacker. And here, states 5 and 3 are also indistinguishable because we have identical situation from states 2 and 4. So if we observe, for example, A, B, and D, we actually don't know if we are in states 3 or 5. And so this definition actually formalized from using this definition, we obtain two relations, one for each attacker. So, for example, in here, I also noticed that each state is also indistinguishable with itself, and this is the formalization of this definition that I just explained. Then the first step is to take, because, like I said, we don't know which attack is acting, so we have to consider the effect of the null acting. So what we do now is to take the union of each relation of the last step. So now we have a relation that represents the action considering all attackers in the attack set. Then this definition is formalized in here. The next step is to consider that two attackers can cooperate with each other. I know that I just said that there is only one attacker acting at the same time, but when we consider, just in a hypothesis, we consider that two attackers can act together. It allows us to find if there are two attackers that can generate the same observation from two different strings, and that's one of the key point for the checking the observability for an attack set. So there are two ways they can cooperate. The first one is by transitivity, where if we have a state Q1 and Q that is made and distinguished by the action of one attacker, and then we have second state Q and Q2 that is made and distinguished by the action of the second attacker, then states Q1 and Q2 are indistinguishable if we consider that both attackers are cooperating with each other. And this can be obtained, the pairs of states that are obtained by this kind of cooperation are obtained by the pairs are obtained by the composition of the relation pi A. The second way they can cooperate is when we have a common state. So in this case here, if you have a state Q prime and a Q1 prime that will be indistinguishable because of the action of an attacker, and then if you have states Q prime and Q2 prime that are made distinguishable because of the action of the second attacker, then we can say that Q1 and Q1 prime and Q2 prime are also distinguishable because the first attacker, if we observe A, for example, it could be the case where actually event B happened, but was erased by the second attacker, and then the first attacker inserted event A. Okay, so what we do next is to combine these the two ways they cooperate, and we obtain the relation pi square A. And in this case, from the run example we are using here, we can notice that the pairs 0 and 2 are originated by the composition of the relations pi A. Another thing that is important when we are studying the observability for an attack set is that we need to consider the states where we have consistent control actions. Because back in the original definition of observability, we are concerned with strings that require different control actions that can be translated to states where some events are being disabled and the same event is being enabled in the other state or the other way. So we build a relation of controlling consistent states where you have that consists of pairs of states that one of the states require consistent control action. Okay, so finally we can present the final result of this chapter. That's the theorem 3 that says that a language K will be observable for the language of the plant and for an attack set if and only if this expression holds, and it means that there are non-common pairs of states that are unchangeable because of the action of the attacker, considering that case the two attackers can act together with the relation of states of controlling consistent states. In other words, if we cannot distinguish between the two states, they should not require different control actions. And we can use this result to make the test, to test if a language is observable for an attack set by checking if this interception holds, it's empty or not. So, for example, the example we are using here, we have the relation pi square A. We have the states, the pair 3 and 5, because and also in the relation of controlling consistent states, we have the same pair. Because as you can see here, in state 3, event beta is being enabled, while in state 5, event beta is being disabled. So we can conclude from this that this language is not observable for an attack set. Okay, so now I'm going to start on my latest developments that's related to the persistent attackers. And what it did here, when I was studying this, the P-observability properties, I actually, I was always asking myself, because I know that the assumptions we made back in the previous work are not very realistic when we consider a real system, a real scenario, a real case of control system, because we don't have the control channels, the communication channels are not divided. They are shared by the actuator channel and the sensor channel. And also, it's not very realistic to consider that only an attacker in the attack set will be acting at the same time at a given time. So we try to propose a better attack model that would describe attacks on real scenarios. What we did actually was, first I built the security testbed first, and I had some ideas when I built it. I had some ideas to propose a new attack model, and then it resulted in the chapter that I will present now. That's related to persistent attackers. Okay, so an attack A is characterized by the subsystem GI and the attack, and an attack function at A. This attack function will guide the attacker how to choose its next action so it can accomplish its goal. In this case, we use the notation L of A slash GI, subsystem GI on the attack A. And the attacker that we introduced here is the persistent attacker. Even when it's acting, it will make the system, the behavior of the system under attack and without attack are undistinguishable. And this is formalizing here in this definition. Basically, we are saying that we use this projection P of n in here to represent the behavior of the system under attack from the point of view of the network, where we have the detection module, intrusion detection module, and in this case, what flows we want our attacker to achieve. First one is to cause the production of OPEX specification products, to insert delays in the production process, and most importantly, it wants to remain hidden, because if it's able to remain hidden, so it can act multiple times, right? And I'm not saying that it will always be certain delays in the production process, always causing production of office specific projects. But the attacker may have the possibility to choose what it's going to do. But the main characteristic that should after this the we are considering here the setup. We consider that we have a control system composed by multiple subsystems. We have a controller, and each subsystem can exchange information with each other and with the controller through a bus network, and also have an IDS that's monitoring the system. So when I say that the attacker should remain hidden, it's basically remain hidden from the IDS, because that's the entity that will detect the attack. And also, there are different attack locations, right? We can have consider the attack location. One is where the attacker infects one of the devices on the subsystem, or we can have an attack location two where the device that was infected is the controller. In this work, we consider that the attacker infects only one of the devices, or one of the subsystems, and we also assume that the attacker knows the models of the models of each subsystem, and has knowledge about the physical process. And this is important because there are some characters that we want our attack to have. I said that our attack wants to remain hidden, but it's not only hidden from the IDS. It also wants to remain hidden from a human operator that's nearby the process. Because if the attacker makes something that's from the IDS point of view, it's the legal behavior of the system, but for example, it can make two machines to collapse, or may make a tank overflow. It can be in the legal behavior of the system from the logic point of view. But if we have a tank that's just overflow, it will draw the attention of a human operator that will investigate what caused the overflow. So the attacker will likely to be discovered. So that's something that we do not want for our attacker. So that's important for attacker to know the physical process, because the same action of different kind of process will cause different impacts on the real process. And another thing is that although the attacker, when it has infected a given subsystem, it potentially has the ability to insert events to the network to prevent the device to receive events that came to the network. It can prevent the subsystem also to send events to the network, or can insert events only for the subsystem observation. So the attacker is very powerful in this case. But if the attacker wants to, for example, to start operating, making the machines operating and stopping whenever it wants, again, it would be because the attacker may do this and while not transmit anything to the network. So the IDS will see nothing, or at this point, everything will be okay. But if someone is passing by, it will notice that the machine one of the machines is operating in an abnormal behavior. So this again will draw the attention of a human operator, and again something that will not desire for this attacker. So we restrict the attacker to attack only uncontrolled events, and we did this because, like I said, this reduces the chances of the attacker to make something that will draw the attention of an operator. And also, it's not a very strong restriction because we can cause the same kind of the attacker can achieve the same goals by acting on the controllable or uncontrollable events. But okay, we restrict the attacker to act only on uncontrollable events, but still that we have to restrict the behavior of the attacker, because it cannot even attack only on controllable events. It can also, if it acts without paying attention to what it's doing, it can make the attacker to be reviewed. So we restrict the attacker to act only on, actually it can tamper whenever it wants with events that are self loops, or if an event causes a state change in the plant, it will only insert this event to the network after the event was originally erased. Because it is because it wants the controller to the supervisor. If the controller has supervisors, we do not want to make the state in the supervisor change before the state, because it can sometimes for the supervisor, the controller will issue some actions that are not feasible in the attacker, and a string S composed by one event or the string epsilon. Whenever the attacker, in this case, if the attacker is using the passive mode, the only action it can take is to repeat what just happened in the plan, right? In the delay mode, the attacker uses it when it wants to delay events. So what happens in here? If it's a control event that just happened, the only action for the attacker is to repeat the event. Because, like I said, we do not allow this attacker to act on control events. If it is an uncontrolled event, then can choose between doing off as well, or to insert an event into the network, which is represented by the subscript plus M. But it can only insert events to the network if the two conditions in here hold. The first one is that the attacker event should be feasible in the current state estimate of the plant. That the state estimate is the state estimate done by the subsystems, the network, that's except the one that's infected by the attacker. And only it's a language that has only strings that's finished with the events that represents the erasure of the original event. So that's it. The attacker if it wants to insert events in the network, it has to check. It can insert whenever it wants. When it's self-loop, or if it's not self-loop, it has to be erased before the event. And the events to the network. And in this case, the only condition is that the events should be in self-loop. So the attack can only anticipate events that are in self-loop. Okay, so the first theorem, the result of this chapter, is the theorem 4, that states that if an attacker A is associated with an attack function, one of the attack functions that I just present, then it will be an attacker, right? This definition, the privilege that I just presented, is the definition of a persistent attacker. Okay, so for example, let's see how these attack functions work. In here we have the passive mode, and we are going to consider this automaton that will be under attack. In here we have event A that's controllable, the other ones are uncontrollable. So in the passive mode, you can see that whenever happens in the plant, the attacker just can, the possibility of the initial state. The only option for the attack is to let the events that happen not touched, or do nothing when nothing happens in the plant. In the delay mode, if event D, which is uncontrollable, happens, the attacker erases it, and then it's the network, which represents plus N, the network. If the event A happened, which is a control event, then the attacker need to let this event untouched. And finally, the forward mode. The only option for the attacker to insert event deep to the network that initial state at any point, or if the legitimate event happened, it just can let them untouched. Okay, so the attacker, these three functions, they attacker can change between them and also can do different kind of attacks for different events at the same time. So the attacker can actually use a combination of these attack functions. But to combine these attack functions is not very simple, because when they are combined, they can reach some of the states in the system that cause the attack to be revealed. So we want to, since we are designing, we want our attack to be persistent, we want to avoid the attacker reaching such states. So for this, we propose the design method for this kind of attacker, which consists first we build a plant estimator, then a network estimator. I will talk about them after this. Then finally obtain an attack structure that is the combination of these two attackers, the two estimators. And finally, in this attack structure, some of states, exposed states appear, and we remove them the last step to obtain defining the non-exposing attack structure that can be used by the attacker to guide its actions. An example, the idea of the plant estimator is to build an automaton that shows what the attacker knows about the system, what the system sees, considering its own actions. So let's consider this automaton here. Here it's uncontrollable, so it's the only thing that will be on the attack. The first step is to add this state XB to that guy that's present for the network. This event B, this state B represents it's important for the attacker to know that something is happening. The attack is being executed. Then the next step is to connect all the original state to that where event B is visible. They are generated for the state, and we add the same transitions in the state XB that reaching the same states that the original transition. So that's why we add here in state XB 3 transitions. And finally, we add in here the subgroups with event B plus N. And again, event B plus N represents that the attacker is inserted event B into the network. And because the event was inserted into the network, it was not seen by the subsystem. So it doesn't change the state in the subsystem. That's why they appeared here as a self-group. Then we built, before that, we just have this lemma 2 that shows that the behavior on the attacker using one of the attack functions, the 3 attack functions that are presented, is captured by the behavior of the plant estimator. Then we build the network estimator. That estimator is an automaton that shows what the attacker knows that the system is seeing from about the system, but also considering its own actions. Again, we start with the same automaton as previous in the previous example. Then we add again next state XB, but now it's reached when the attacker inserts an event to the network. Then we again add the same transitions in here, connecting state XB to states 2 and 1 and XB itself. And finally, it's not final because there is a last step, but now first we add a next state, state XZ is a state that's reached when the attacker makes the attacker do some action that will review itself. For example, it's the initial state, event B is not feasible. So if by any chance event B happens, or the event B plus N have the attacker chooses to insert event B into the network at the initial state, then we are going to reach state XZ, because it's exposing the attacker. We notice here we do not have to be worried about the event A, for example, happening at state 2, because we consider that our controller, it knows that the event B, event A is not feasible at state 2, so we do not trigger event A from state 2. Okay? With controlled events, you do not have to worry about, only with uncontrolled events. And finally, we have we add self loops with event B plus minus n, because in this case, events B minus n are happens that are events just that happen in the system or prevented to reach the network. So the network does not see what's happening in the subsystem. So that's why it does not change the state, the network state. And finally, have lemma 3 that says that the behavior on the attacker of the system attacker, considering the 3 attack functions that we just presented, is also captured by the behavior of the captured by the network estimator. Then the next step is to combine these 2 estimators that will result in the attack structure that of GI. It's obtained by the parallel composition of the 2 estimators. Then in this attack structure, some the exposing states may appear that in an exposing state is when in a state in the attack structure that the label corresponding to the state in the network estimator is equal to XZ. So whenever state XZ is reached in the network estimator, it's stated that where the attacker is being reviewed. And we do not want these attackers, so we will remove the next. But first, here with lemma 4, we are just formalizing this, saying that whenever next state is X state XZ is reached in the network estimator, it means that the language, the string that was executed by the system attack, when seen from the network point of view, is not in the label language in the of the planet, the subsystem GI. So what we do now is to remove these exposing states by applying the string operation, and we obtain the non-exposing attack structure P of GI, and we theorem 5 we want to say that the behavior of the attack, considering the 3 attack functions that we presented, is also captured by the non-exposing attack structure. And finally, I will give the example first. Here, considering the estimators that we built before, we do the parallel composition of them, and here we find that there is an exposing state that's reached when the attacker chooses to insert event C. Sorry, this should be event B. Sorry. So if the attacker wants to insert event B into the network at the initial state, it will reach the exposed state, and so we need to remove it. This is done by applying the string operation. So we will result in this automata, and this is a non-exposing attack structure can be used by the attacker to guide its actions, and to perform the attacks while remaining from the IDS. So, for example, if at the initial state event A happens, because A is controllable, the attacker will not reach event A. Then at state 2, the attacker has 3 options: to erase event B when it happens, to do nothing with event B when it happens, or to anticipate event B. And from now on, the attacker can use one of the feasible events here to guide its action according to what it wants to achieve. Then we have theorem 6, the last result, this chapter, that is the dual of theorem 4. In theorem 4, we state that if the attacker uses one of the attack functions that are proposed, then it will be a persistent attacker. In theorem 6, we want to say that if the attacker uses the non-exposing attack structure to guide its action, then it also will be a persistent attacker. Okay, so now I will present the results that related to the implementation of a security test bed. Like I said before, this chronologically this came before the latest results on the resistant attackers, and they helped this idea of building this subsystem. It was when I was working, like I said, with the observability and attack set properties, because we saw that some of the assumptions were not too realistic, and we wanted something we could test our theoretical results, and the idea was also to get some knowledge from the physical processes and regarding what we needed to do so theoretical results could be applied. What issues could be would appear when dealing with such a physical system. So we want something closer to reality, and we decided to build something, a small system, so we could test, it could get knowledge from it. This prototype, it also actually consists of a prototype of control system, where the physical system that is being simulated is this one. We have a tank with input valves and output valves. We have a level sensor, a mixer, a heater. There is a pump in here. So the idea of the physical process is the production of batches of products that are made by mixing some different kinds of products, and then the reaction happens in the tank to control the temperature and so on. And for example, so I said this physical process was simulated in hardware because when I built this, we were during the pandemic and the university was closed, so I had to build this at home. So I wanted something real. So, but the part of the physical process was not so important. So what I built, I'm going to show later. But there is a prototype that where have a control system with real devices that exchange information with each other. This is physically implemented, but the part of the control system, the physical process, like the temperature control, was simulated in hardware, because this was not the focus of the working. So in this process, we have different devices, and we can here consider that an attacker can act on these devices and change the information that they are receiving or sending to each other. So, for example, if in here in the level sensor, an attacker infects this sensor, it can change, for example, when that sensor will send the information to the controller. So, for example, if the tank is being filled, the attacker can send an event to the controller, telling the controller that the tank is already filled, when in reality it's not completely filled. Or, for example, the attacker, the desired level, the level reaches the desired set point, and then the attacker, the sensor will send a signal to the controller, but the attacker chooses to not let this event be sent to the network. So what will happen is that the tank, the input valves will remain open, and what may happen is that the tank may overflow. So that's, like I said before, we assume that the persistent attacker, when it knows that the overflow may happen, will not do this kind of attack, because in here it can make something happens that will draw the attention of the operator. So here we can simulate the different attacks where the attacker insert events to the network, you raise them, preventing them to reach the network, insert events only for device observation, and so on. And also the attacker may want to infect the controller. The controller can do the same actions, but it's more, it will be more powerful, because in here the attacker has access to all the communication between all of the other devices. Another thing that is working here was presented in the last words. in September. And in here, in order to the contributions of this part of the work is that in order to implement the control, we had to propose a scheme for the implementing the TS controller, because we assume that in here the controller is the one, because the supervisor itself is not enough to make the control the DS control. You have to have something that will choose between the events that are feasible, one event to be triggered and sent to the plant. The plant will answer to this event with some uncountable event, and the DS controller will update the state of the supervisor, and the new set of feasible events may be available, and then the supervisor, the controller will choose one event to be sent to the plant, and so on. But this scheme is actually implementing this topology here, where we have a controller and a canvas network with multiple devices connect to it. We have a SCAD where we can, observe the process, and to combine these two things, this scheme, the DS control feedback loop, with the topology, we actually had to build this DS control architecture, where we have this in the top here. The control events to be sent to the network, and these events are received by the devices. Notice that all the devices receive the events that are sent. Once the event is sent to the network, all the other devices will receive this event, but they are going to choose which one is going to be accepted or not. So, and we had to do this because we wanted, since we are studying attacks on discrete-event systems and we are dealing with events, we needed to have events being transmitted. So, and in here, this in the network interface, this block in here is the block that handles the communication, the incoming and outgoing communication, and it's where we allow the user of this testbed to change the code to simulate an attack. This is the prototype that was built. Like I said, the physical part of the process was simulated in hardware. For example, the temperature control, the dynamic of the temperature control was simulated by an RC circuit, the valves and mixer and so on. They were simulated by an LED, but the device, the communication between devices was built physically. We used Arduino boards to make this, to make the different devices, and I had to attach to them communication modules so they could exchange information with each other. And we also, so we have an SCAD as well that, like I said, allows us to monitor the process. And all of this information is shared in a online repository. So other people can reproduce this and can modify whenever they want, where they want, and they can also use this to test their theoretical results. Regarding the software, I built the CSIT library that will handle all the dynamic of the DS control. This library offers access to incoming and outgoing events. So that's, like I said, it's where the user has to change the code. So to implement an attack or to implement a defense strategy. So what's happened? What happens is that here is that we have the system is already implemented, and what the user has to do is to insert. We changed to have to put all the communication from outgoing from event. So it's easier for the user to change to simulate an attack from there. And it can also add an attacker as a new device in the network, or it can add defense strategy as well. So it's open access, so everyone can change it as they wish. Finally, I'm going to present the conclusions. So this presented some contributions related to the observability and attack sets. There are some work to be done. I will talk the next slide. To also introduce a new type of attacker as well, design technique for it, and that are the persistent attackers. In the context of TS, we did not see this before. The proposed attack model considers attacks in the device instead of the attacks in the communication channel. So it can, it's different. You know, it tries to model attacks that happen in the real world besides the attacks on the communication channel. Implementation scheme for DS control net, much reasonable assumption. Much more reasonable assumption. To validate, we want to validate the design technique in the test bed for the persistent attacker. We didn't do this before because we did not have the time. Because, like I said, since I built the test bed and starting to use it, then I got some ideas from about the attack model, and I had to start work on the theoretical results, and I did not have the time, the opportunity to test the validation. But also we want to propose a design technique for persistent attackers when it's attacking, for example, the controller. This is a step of my work that I intend to continue, because that's where going to be a difference between the works that already exist in the literature. Because like I said, most of the works consider attacks on the communication channel. You have the same observation, and when we consider that controller, the attack is in the controller will have different observation from the IDS or different from the other device in the network, and that's when we have going to have a big difference. I also want to propose a defense strategy against this kind of attacks, persistent attackers. Probably I would have to work with time to be able to detect them. And regarding the test bed, I will implement this computation tool for the automatic generation code, and as well as the different kinds of attacks. And I want also to implement an architecture of TS control centralized controllers, so we can apply security issues in this context. So in here we have the reference that I see in the title of this presentation, and I would like to thank you for your attention. And that's
okay. So thank you, Michel. Next, we move to the next phase where yes, questions. Usually, what we do is university. In this case, it's going to be that is from Santa Catarina. Then Lilian will follow, that she's from Rio, and then Professor Takahashi, that is, and then Carlos André. So talvez botar. So Max, go. Max, open your camera. You can view on the screen.
Good morning. Can you hear me? Please let me know if my audio is okay, because my audio, I can hear it. I can't hear it very well from here, but please let me know if you can hear me.
I hear you.
Okay. Okay. I will talk slowly and well, first of all, thank you very much for the invitation, Michel, Patricia, and Karen. I'm a big fan of Patricia and Karen. The first seminar I presented in my master's studies that was about a paper José asked me to study is think globally and act locally, and so it was my introduction to partial to supervisory control under partial observation. It's a very nice paper. Thank you, Karen. And it's a great honor to be in this defense that is co-supervised by Patricia and Karen, and where it presents, it deals with partial observation too. The most important result of the PhD studies is not the thesis, is the PhD researcher. So I will start by congratulating the work, the quality of the formation, the studies, the graduate studies that was in this was behind this work. It's a theme that deals with formal results and also with practical results. It's original and challenging for the formation of Michel. It has this also. I would like to highlight the importance of international cooperation in these studies, and this is something very important for the formation of for the graduation of Michel, and also I would like to highlight that Michel has already 2 publications, one in WODIS and the other in JDADS. Is that right? Is 2 publications on this?
But I had another one that's not related, actually related to my master's.
Okay, but about this PhD studies. So this is something also very important. So and for me, it's more important than the thesis itself. So the publications, it's a certification already of the importance and the quality of the results you have presenting also in the thesis. So in order to make my comments on the document, I would like to propose, maybe it would be simpler if I can share my screen with my notations on my commentaries on the document, on the draft of Michel. Is that all right, Patricia?
Yeah. Yes, you can share. I think
Okay,
you
so
can share now.
I will share here. Okay. Well, I think I liked your oral presentation. I would like to say maybe you have complemented with some relevant information that I think was missing in the thesis. Maybe you could be a little bit more concise in your talk, but I understand that presenting in foreign language sometimes is a bit challenging. So even for me, as you can see. I will start, so I will pass in the document. The document is very well written in English, but maybe in the Portuguese part, in the title, a review was missing. There is no crazies in this A, okay? So another point, you have many contributions here, but this contribution is a bit scaring for me because you are proposing a technique, a design technique for persistent attackers. When I read this, is something dangerous you are presenting in your work, and there are some ethical issues that I think is important to discuss, and this is important in the PhD education, because we are engineers, we are researchers, and we are responsible for the consequence of what we present, okay? And there is no discussion in the previous commentary, only a small note in the conclusions. You say that that may help to improve defense techniques and is useful to improve knowledge. Okay. I'm sure I have intentions and the best purpose in this, but in the introduction, and I'm sure in any paper you would submit on this kind of work, it's very important to make some discussion on ethical issues and to present very clearly the purpose of, and it's something very dangerous, and it can have such a kind of attacks can have very dangerous consequences. One of the most evident attack was the attack on the uranium enrichment centrifuge in Iran, and it was a kind of persistent attack that was degraded the centrifuge. So it's very important to put this issue, okay? There are very small observations. I will pass the draft for you. I will not pass for all of them, okay? Okay, that's all right. This is what this work of Carvalho and Lima is Lilian here, isn't it? What is the man in the middle attack? Because you have presented some in the previous discussion some classification, but you didn't explain what is the a man in the middle attack.
Yes, the man in the middle attack is an attack that it happens mostly in the data transmission layer, because it's an attack where the attacker is able to intercept all the communication between the devices. So it can change if it's able to read the message that are sent, because sometimes the message, change everything. The communication can affect. The attacks, when we model the attacks in the communication channels, these are kind of attacks, the main domain attacks, because the attacker is able to intercept the communication, to change, to erase, to insert events. But most of the attacks are actually the main middle attacks. The ones that I proposed as well are main the middle, but they are main the middle, but they are not in the communication channel. They are in the device interface, the network interface of the device. Yeah, but I should have add something explaining what are this kind of attacks.
Okay. Okay. Here this is something was a bit confusing in this work that there are 3 Alves in related works. Authors. Okay, maybe if you could cite the first and the second author and all, it would help to clarify. This paragraph was a bit confusing. Which one is you and the others? Maybe if you put two authors in the reference before the end, it would help the reader to follow. Okay. Okay, this is some small points I will not discuss. Pass rapidly. Okay, this is something I think you should put in. One of the goals of your thesis is to have a model that can capture real-world attacks.
Yeah.
I think this is something very challenging. You know, when we think in your, sometimes we deal with some academic, if you think the evolution of the knowledge in this area, sometimes we start by very academic examples and improve the techniques, and it takes some time until we can reach real world attacks with all the details of real world. Okay. And this is the issue. What you mean by real world attack? Can you your direct solve? Can you your technique capture actually ready to capture a real world attack?
Yeah, I agree with you that the research we start by making any assumptions and then little by little to drop them. Maybe I would say that my work is not exactly, we cannot still yet to apply real world attacks, because we have, the problem is that the devices we are using are the testbed are not industrial devices, so it's in order to accomplish a real attack, we need to be a very ideally we would have to have industrial devices, so we can actually try to first we was try to study how an attacker would infect such device, and then the next action would be how can an attacker can act once it's already inside the device. So yeah, I agree that many steps that we have to make yet, so we can really apply to discuss attacks in real world. I wanted my thesis to bring to propose an attack model that was closer to reality. That's why I proposed an attack in a system where we have a controller that's sending a message, and the attacks can happen in the device. But I review that's not. Still, we have to keep working because we made some assumptions still about the attacks, and but I think it's what we did here is very valuable because we're starting to look at the real system instead of only considering systems that, theoretical examples. I'm starting, like I said, I know my example is not the what's happening in a real industrial system, but I think that we are starting to look into something that's closer to the reality, and we are starting to see what kind of issues we have to deal with when we consider such systems. Next steps will be to probably to improve this or consider even more realistic scenario for the attack and so on. But yeah, it's not maybe the way it's written that try to you can for that we are solving the problem, but we still have some steps to take on our own.
Okay. Another question. In your attack model, the attacker's goal is to prevent supervisor from achieving the desired language. Okay, that is continuing is a sublanguage of the behavior on the discrete event system. What do you mean by achieving the desired language?
Yes.
Because a language is a set of all the sequences, all the strings that may happen in the system. Okay. What is to achieve? You mean that all the possibilities must remain? Let's say the closed loop system must be equal to K, or to be a subset. But if you
that's.
For example, if you avoid all the events in the initial state, epsilon, for example, would be a string in K. What is what do you mean?
So that's this chapter, chapter 4, I was about the result of P-observability and attack set. And in this case, the attack model, the way it's written there is the idea of the attack is to prevent the supervisor to enforce the language K. And by this, I mean that there are two ways. The attacker may want to act on the system in a way that the supervisor will do something that's not in K, that's a language outside K.
Oh, okay.
Right? So,
okay. Now I understand. You want to prevent to trespass, to go outside K in a language, in a string that is in L, and is not in K. Okay.
Other thing that can happen is that when I say that preventing to achieving K, is that a given string may be in the language K, and the attacker will do some action so in a way that the supervisor will not allow the string K to happen. That is also a possibility.
Sorry, I didn't understand the last word. Communication is not good at. You mean blocking?
For example, or something that's in K, but the attacker does not allow it to happen. The possibility as well.
Okay, and
ideally, we want the supervisor to enforce the language of the central control. We will be
by the alphabet that is attacked by the hacker. Is that right?
Yeah, exactly. The problem when it's not the problem, but when we consider TS, we are looking only for the logical sequence of events, but there are the time is there. So there are multiple ways that the attacker can act respecting or changing the behavior that can sometimes have the same sequence of logical sequence of events, the same, yeah, and different. The time of each sequence is different. The time between events that can cause impact on the system, like I presented in the parts in the when I talked about first attackers. But that's it. There are, yeah. I don't know if I answered your question.
Okay. Now, for me, it was a bit strange that I use alpha as a set of strings. Usually, it's an event, but I think now after I read it, it was okay. But this map are not a alpha. I think it is a map that presents attack here. Is that right?
Sorry, I didn't.
This map here, move some event.
We have to use together to describe the attack. The first one is that the one that we showed here.
It is not alpha.
That represents
the removal.
Yes, it represents
alpha
the
removal. Okay.
removal.
Shouldn't it be a map from sigma O to sigma O minus alpha or epsilon? Because you
because you are
you use it for strings U in sigma O star.
Yeah.
What's the difference in this map to a natural projection?
Yeah, this map is actually very similar to a natural projection, but the way it's defined, it's the opposite. Because in the natural projection, we kind of when we define a natural projection, we define the sets that from which we'll keep the events, right? So we are projecting for a smaller set, bigger sets, for smaller sets, and keep the set. This map. So,
okay, so observable strings, events, to sigma O minus alpha, the set of strings that remain, or epsilon.
yes.
Is a natural projection or not? In this way,
Yes.
this A alpha U isn't simply the inverse projection of the projection of U. Or R, if R is if R is the projection R or PA. Let's say the set of
Not
all.
a simple.
Okay, I will leave this for you to look later. Okay. Yes. Your main result here.
I just want to tell that the connection or internet connection is not very good. So
Yeah, for me too. For me too. I sometimes I'm sorry, I can hear it very well. So I will leave the document, and later we can talk directly about this if you want. Your main result here. You define that a property that the language key is P-observable if and only if these relations doesn't have intersection. And my understanding is that this is very close to the relations in supervisor reduction. Is that all right?
yes, yeah, and also this intercept relations is also very close to the original definition of the observability, because the observability on attack set, because in there and the original definition they use the terms of the definitions done by terms of strings, and I kind of translated this to work with state instead of strings, and yeah, but it's also close to the other.
Okay, so if we take a supervisor and we reduce a root supervisor, okay, and a set of events, say alpha, the set alpha, only occurs in self loops. Okay, so that means that the events in alpha are not relevant to the supervisor to change the control action. Isn't this a sufficient condition for P-observability or not? This is something I will leave for you to think about.
Yeah, that's a good point.
Okay, well, chapter 4 I will leave for Lilian. It's I'm not an expert on that text, but there is something general. The results in this chapter. It's the only chapter that has no paper already. You have already some submission of these results?
We are preparing the submission. Yeah, we did not have submitted yet because I had to decide if I was going to write a thesis or to publish, send this, submit some paper, because unfortunately I had the deadline for my class was closed, so we had to choose. But it's, I am going to take this text on this. I will get your contributions as well and write a paper to submit some journal. The next step.
Okay. Okay, you assume this in your implementation architecture. You assume that the controller will always send the controllable events, okay, to the plant, and the plant will return with uncontrollable events. Okay. In our experience, that's mostly true when you say we think about a PLC that is commanding some machines, and so the outputs are controllable events. That makes sense. But sometimes when we have interaction with humans, is different. Okay, some events fits very well to the assumption in Ramage 1 and a framework that events occur spontaneously by the plant. For example, in our case, the start button. In our example of Woods 2020. The start button is something that sometimes the controller needs to disable for the user to avoid starting a process in some unsafe states. Okay, but it's not the controller who will decide when the user may want to press the button. It may disable, but the event is the controller will only observe the occurrence of this event eventually when someone decides to press the button. Okay, so this is something that sometimes you might want to consider also other kind of communication. I like very much this structure. Okay, I had some questions on how can you synchronize the same models here in the product system that are in the local product system. So they are duplicated. There is some synchronization, but I will leave it later for another opportunity. So it's the issue of inexact synchronization. That was my question. I like your presentation. You show the interface, the user interface of your software, and in section 6. I think this was missing. How can someone that will use your framework here, your testbed, how can one simulate or perform a cyber attack and visualize the results? This is missing on the document, and especially, I think that it would be fine if you show an example in your results of a cyber attack using your testbed. Okay, it could be very short presentation, but I think it would be very useful for someone to understand how can we use and what kind of attacks one could test. Okay. I have some issues, some question on how to force events in your modeling, because it's a bit different on how this was an issue on our implementation that you said it inspired your work, but if you have such kind of specification that, for example, the input valve can only close after the tank is full. But if we want to, for example, avoid overflow, it's not this kind of specification. We need to specify that the valve must close when the tank is full and before some uncontrollable event. So this is some forcing that is not on the standard framework of Ramage 1 supervisor control. it can be. But we have presented in our paper some strategies for modeling preemption and assuring that this kind of specification can be performed without having to consider forcing of events. Okay, so that's it. Congratulations one more time for your work. I think you have an important, relevant contribution. I think both on theoretical, formal results and on some practical contribution, and that may be very useful for the community, and that's it. Thank you very much for this opportunity to be here.
I would like to say that when Patricia suggested you to be part of this committee, I thought that it was a good idea, because she told me to that you usually work with some real application. So we knew that we would bring some good suggestions and remarks to our work. That was very nice. Thank you.
Thank you.
Okay, thank you, Max. Thank you for all your comments. I took a notes of some of the things you said, and we will take.
Patricia, can I see the next? Can I skip it?
Yes.
Patricia, eu posso ser, melhorou? Eu posso ser a próxima?
Pode. Com certeza. A gente escutou.
Ah, tá.
So Lily is asking to be the next one. So I'm going to invite Professor Ricardo Takahashi to make his considerations. Maybe you should turn that.
Yes.
I don't understand Portuguese, but I think I understood that point.
No, it's because Lily asked to be the next one.
Yeah.
I think you heard the
I
baby.
understood. No. I'm saying I understood the essence. Yeah. Okay.
Obrigada.
Can you hear me from here?
Karen, can you hear him?
Not so
I can
well.
Let me change. Perhaps from here, it's better. Yeah.
That's better.
Let me try. Let me try. Let me first work. And I have just a few questions. Contrary to Max, I should say that I was pleased by the long explanations that Michel provided in the text, because for an outsider like me, this was very useful for understanding what I liked it. I liked the long explanation. And I agree with Max that the thesis is very well written. It was easy to follow reason. As occurs several times, the text was very nice, very up to 2/3 of the text. But in the end, some mistakes were appeared. I have to take here.
pass for you. Let's go to the use of comments. Page 34.
Exactly.
The synthesis of the page. The top sentence. Even when the plant and the supervisor are synchronized frequencies of insertion or visual events, the system keeps work unless the attacker is successful. Yes, it makes the plant reach the desired state. What do you mean?
Yeah, the idea in this part is that the idea of a robust supervisor. Sorry, because the question is sometimes it's not that in order for an attacker to make the plant reach uncertain state, it's not you cannot do only just one action. So the plant go from the legal behavior from the critical state. Sometimes we have to do a set of actions, sequence of actions. So when we start to perform this action, what happens is that sometimes the plant will be synchronized and affect the supervisor. And the idea is that the plant should. Sorry, I did this. Let me just. What's yes. Yeah. So the idea. Sorry,
It's 53. PHP. The paragraph below figure 48. Yes,
yeah.
Say that states three and one are excluded from estimated because in order to make state zero, this information now the two attackers actually automate each other, each by erasing events sigma 7 and sigma 4, which is not allowed.
Yes.
I think that its assumption is something strange for me. I think that you say that such a coordination is unlikely, but the coordination is not forbidden. It may happen.
Yeah. Yeah, that's no, but at the time that we did the publication, I had questions about regarding the paper that suggests that we use. So it's actually difficult to, in this case to find. The first thing is to define the attack set. How can one define the attack set? Because we are saying that how can we choose that find which subset events each attack will act on. So I agree that it's difficult. It's not a simple task to define this. We tried some approach later after the qualification. I tried to make the something about but it was just an investigator. I didn't went further on this, but try to make to consider an attacker that will act on all events, but it would be difficult to defend to defend against it, because if the attacker can manipulate all events, it's easier for the attacker.
I understand your point, but I think that perhaps some more justification.
Okay, yes.
Right? Because at this point, we're somewhat against the basic assumption of the discrete-event system. That it's a very profound idea, and that we will achieve certainty upon our actions. We know that the force of the action would lead to some result. In this case, the assumption is quite different. You have a situation in which you provide some sort of certainty that for most of the attacks it will be okay, but for some of the possible attacks that are included in your assumption that may occur, some of these attacks will be successful and will lead the system to malfunction. But this is quite annoying for the community of the discrete-event systems, I think. So it should not be hidden without some discussion.
Okay. Yeah, I agree, and this work here motivated the following work. That's because we look at this and we know that it's such a word so realistic, so we try to improve on that, propose something that we're not realistic. Yeah.
This is Next question, page 81. Fine. Okay. The figures in figure 511. In this point, we have not told anything about XE. Several pages before this point, after this point, you will say what this means. I think that the discussion should provide before this point, and even the presentation is somewhat after this point. I think it's somewhat collateral. It's not, you don't speak specifically what the XE means. I think we provide somewhat by here and the discussion about what this would mean. I think that in your presentation, you included some information that was not presented here.
Yeah, because this state, it's up to this point in the text, I did not want to say that something about the exposed state, because the exposed state is the state in the attack structure after the composition, the parallel composition of the estimators. But at this point, we have this state XZ that will later can find. We define the exposed state by using this state XZ. But yeah, maybe
I think that don't say this explanation of the page. I understand you can't explain. I think that explanation is not well presented. It may be after this point, but in this point, you should explain this. That this state will be explained. You should say in sentence explain the general idea.
Because this state is important.
I understood some pages after this point.
Okay, yeah.
Seven. Very first sentence starts in the on page starts in page 96. Figure 6.4 again stands for given decision making, which component that has input the control action supervisor. It has the set of enable events that has output a single controllable event that will send the plan.
Yes.
I think that if I understood correctly, this information is not used by the detector, the intrusion detector, as something that will give rise to the information about what is an incompatible state or not. I'm sure I'm correct.
Yeah, yes, yeah.
I think that a logical thing to include information. This would allow you to narrow the possible.
Yes, it's a good idea, because since we, the supervisor, we are only choose among the things that are enabled, all of them are okay they can actually occur. There's no problem in that. But yes, it's a good idea to tell this to the IDS so it can also look if there is one of the friends or not. Yes, it's a good idea.
Next one, page 107. Say that yes. You say that in this implementation, the idea is used to distinguish discrete events from the continuous time variables.
Yeah.
I think that you don't mean exactly continuous time variables, because continuous time variable cannot be seen in a package.
Yeah. Because what I do here is
You should say perhaps the sample data coming from a continuous variable.
Yeah.
Just a small. 109. Yes. This paragraph, you say that the fact that the system, the control, may be blocking, even when the supervisors are not blocking, in some of them issue. It's correct.
Yes, because it's probably have when you have I'm explaining this the first paragraph, but they had when you have even he wants it to reach a market state, but in the path to reach this market state, if you have control events that will it's not that the question is okay, you have a market state and a path on the actual market state of the system to this market state. If there are control events that when they are fired or triggered, they make the system go not another direction instead of going in that path. What can happen is that if we always tell to the controller to trigger control events, the system may never reach the market state, because whenever we are going to the path to the market state, or the controller triggers a control event, so we get out of this path. So it is not
Control supervisors are non-block.
yes.
Close to is non-block.
Yes. Yeah, potentially it will reach the market state. The problem is that the supervisors will, if the way we program this, the controller, they can't always trigger control events. So in theory, it's possible to reach the market state, but
say that the controller falls in the block.
yeah. So the implementation of the controller, that's the difference. The controller, the model, it's non-blocking, but the way you implement it, can cause
It's not clear what you mean. You should try to.
Yeah.
That's 110. Just a comment. By Max about exactly the same market about the substitution on how to use your
Yeah,
system to simulate.
yeah. And I agree that we
Yes.
can add some examples.
Exactly the same as maths.
Yeah.
It's that. Thank you.
I'd like to thank you because you are when you participate in the community in the qualification, you made a lot of suggestions about the realistic how we could if the assumptions that we were made at the time were realistic, and we start to to looking at a more realistic scenario, and all of this led to this work. Yeah.
Good work.
Thank you.
Here's the recap. Now I think André is done, so we can go back to Lilian. Michel, turn
The camera face you? No, it's facing me. Yeah.
Yeah.
Okay. Okay.
Hi, I'm sorry for this change of the argument. First, thanks for all. Thanks, Patricia, Carrie, and Michel to invite me to this presentation. I think the work. I think this work is a PhD thesis. Your work has a contribution. You published this. You are hear me? Yes.
Yes. Yes.
Oh, okay. You published this this part of this thesis, I think, in a paper. Yes, in JDEPS. And your presentation is good, and that this is a little long, especially I think chapter 5. Yes, because I think you are prepared to publish. Yes. I have some questions, a lot of questions. And I asked to Carrie if I can if I can speak in Portuguese. I'm sorry because it's a little bit hard. I think today to speak English.
Yeah, why don't you ask the questions in Portuguese, and Michel, maybe you can, before you answer, just give a quick idea to me of the question.
Oh yes, maybe I can
You speak in
argue
Portuguese.
that. Yes, I can argue him in Portuguese and have some discussion, and then you summarize in English, because the internet, I think, is not really good, and it's hard to for me. I missed some part. Yes. Ok. Então eu vou começar em português, e aí a gente sempre, no final da discussão, a gente faz alguns comentários em inglês para a Karen. Pode ser assim, Michel? Pode, Patrícia? Não, essas internets da universidade estão meio sofridas, né? Não sei se para você está picotando muito.
Para mim está bem difícil de escutar o áudio, mesmo em português está travando um pouquinho. Não sei se vocês estão lá o teu áudio até tá bom, Lilian, mas o áudio ali da sala ali do Michel e da sala, não sei se está no Wi-Fi ou alguma coisa, se não está na internet cabeada, mas tem algum gargalo ali.
Tá. Então, eu queria escutar algumas partes da sua arguição e fiquei assim, sabe? Mas não pesquei. Então, se alguma parte tiver repetida, Michel, você desculpa, porque tá um pouquinho difícil. Mas a gente sabe que o problema bem, pelo menos na PRJ acontece a mesma coisa. Então, vamos começar. Então, o capítulo 2 teve assim, me chamou a atenção, né? E é mais um alerta para você, porque tem na página 9, esse autor aqui, o Wang pede Página 9. Isso, no final, o Wang. Isso, Wang and Pen. Ele fala que o transducer é uma extensão da definição de autômato. Assim, eu li esse trabalho e a minha opinião não foi bem essa, entendeu? Eu acho que você pegou um pouco baseado no resumo dele, esses comentários, ou não? Assim, eu entendo que você leu, entendeu, mas na hora de escrever você se baseou bastante no resumo dele, né? Então, é isso que eu queria te alertar, assim. Eu discordei do começo ao fim do que ele escreveu, e por isso que eu acho que você, não sei se você teria essa opinião se fosse debater sobre esse artigo. Então, para você tomar um pouco de cuidado na hora de escrever, até para reproduzir as coisas, né? Óbvio que a gente não é para escrever mal, né? Mas tem que sempre escrever com bastante crítica sobre os trabalhos, tá? Então tá, isso daí é só um comentáriozinho, não é nada importante. O capítulo 4, eu acho que já foi publicado, também a gente já tinha discutido um pouco na sua... Né, acho que já... Eu só não gostei muito do título, porque para mim ficou mais evidência a P-observabilidade do que o ataque. E eu acho que até no seu resumo, na hora que você apresenta esse capítulo, você fala, então, o que eu fiz de mais importante foi o algoritmo para P-observabilidade. Um novo algoritmo. Não foi nesse sentido? Não sei. Você não está... Eu fiquei com essa sensação, eu estou perguntando para você.
Não foi, o foco era o teorema que permite a gente fazer o teste.
Isso. Então, eu acho assim, não que isso que você fez não seja importante, mas parece que desencadeia um pouco do tema da sua tese. Entendeu? Se você pensa num documento, uma uniformidade, talvez o mais importante é a parte do ataque. Então, talvez...
Um trabalho que a gente desenvolveu, né, até, sei lá, metade do doutorado, então, quis colocar isso, porque, né, trabalhei principalmente...
Não, eu não estou falando para você não colocar, eu só estou falando para o enfoque, o título, não sei, um novo teste, entendeu? Você, na verdade, vai utilizar um novo, né, assim, você fez a parte do ataque utilizando um novo teste, entendeu?
Entendi.
Mudar um pouco a ordem.
Entendi. Tá, ok.
Tá? É só para você não chamar muita atenção para... Claro que isso é importante, mas eu entendo que dentro do contexto da sua tese, que é ataque, isso ficou um pouco diagonal, assim. Ou não, ou você acha que isso daí é a aplicação que foi ataque, mas a P-observabilidade, que aí teria que mudar o título da tese.
Não, assim, eu acho que esse capítulo, ele está... Assim, a gente deu uma guinada diferente, né? Porque a gente, nesse capítulo 4, P-observabilidade, no final das contas, é uma propriedade que a gente usa quando a gente quer estudar uma estratégia de defesa, né? A gente faz também um supervisor robusto no ataque. Depois disso, desse capítulo, realmente mudou um pouco a direção que a gente foi para o design de atacante. Então, assim, não é uma continuidade, né? A resto da tese não é a continuidade desse trabalho, foi outra guinada, assim, a gente teve alguma...
Não, sim, não, mas eu estou discutindo mais, assim, olha o título do capítulo 4. Um novo teste para a P-observabilidade. O que é, entendeu? Para um conjunto de ataques. Então, meu ponto de vista, ficou muito mais importante a P-observabilidade do que o ataque, entendeu? Eu só tô, assim, é só um comentário, tá? Como a gente está falando em português, a gente está falando aqui, né, 20 vezes mais, mas... Karen, we will only discuss about the title of the chapter. Okay?
Yeah, Patricia translated for me.
Okay. Yeah, it's not a big deal. I only discuss with him about this. Tá bom? Então, só para você pensar, não é nada assim muito importante. Então, vamos para o capítulo 5, que foi o capítulo também que eu me detive mais. Achei bem interessante, né? Você colocar que você tem essa nova forma, né? De você ter o lugar do ataque, né? Que você falou que não é mais no canal de comunicação, e sim no device, né? Mas faltou para mim, assim, estou falando em termos de motivação, né? Um exemplo de aonde, mas isso em termos de modelagem, aonde isso vai interferir? Entendeu?
Tá.
Porque isso com certeza vai vir na hora que você deve estar escrevendo um artigo com essa parte, não é isso? Então, aonde existe diferença? Não existe? E aonde é?
A diferença, então, quando a gente passa a considerar o ataque pode acontecer no dispositivo, e aí, assim, basicamente, a grande diferença é que a observação dos dispositivos vai ser diferente. Por exemplo, se um ataque está acontecendo no subsistema, tá, que eu considerei aqui. Então, por exemplo, o controlador e o IDS têm a mesma observação. Mas se é um ataque que acontece no controlador, e aí assim, a observação do controlador e do IDS vai ser diferente. E aí que vai fazer grande diferença, no final das contas. Porque o atacante tem que estar... ele quer ficar escondido do IDS, ele quer atuar no controlador, só que ele tem que entender que o controlador está vendo é diferente do que o IDS está vendo. Então, ele vai ter que escolher bem quais ações ele vai ter que fazer para poder fazer o que ele precisa no controlador para atingir o objetivo dele e ficar escondido do IDS. Realmente é isso. Poderia realmente, eu concordo com você, dá para a gente destacar mais essa... O que muda, né, de quando a gente está considerando o ataque.
Eu achei que você deveria já abrir, assim, o capítulo um pouco com essa discussão, entendeu? Porque você discute bem, eu estou fazendo alguma coisa diferente, né? Eu não estou colocando o ataque no canal, eu estou colocando o ataque num dispositivo. Aí agora, dado que eu estou colocando no dispositivo, o que vai mudar isso, né? Qual é a consequência disso? Então, você está falando que, como você está modelando, e também não ficou tão claro para mim, que no início do capítulo 5, que você estava querendo modelar o ataque. Então, você está trabalhando o tempo todo com ataque. Na modelagem do ataque, para o ataque ser bem sucedido, é isso? Tá bom. É porque, para a gente, né, quando a gente escreve assim, tudo é claro. Mas para o leitor não é tudo claro, nem tudo claro, porque, por exemplo, na hora que você descreve um pouco sua estrutura no capítulo 4, no capítulo 5, desculpa, passa um pouquinho, na hora que você monta a sua estrutura, você começa a falar em controle modular, em controle aí. E aí eu fiquei meio perdida, eu fiquei assim, mas qual a estrutura que você está usando? O distribuído, em rede? Estou perguntando.
Não, então, eu assumo que tem um controlador centralizado Os demais dispositivos estão numa rede, um barramento. Então a ideia é que todas as mensagens que são transmitidas na rede, todo mundo recebe a mensagem, e a mensagem, cada dispositivo tem a capacidade de avaliar se a mensagem que ele recebeu, ele vai usar ou não, baseado no poder que ele tem internamente. Então é isso, é essa a ideia, por enquanto. Assim, é um controlador centralizado com vários dispositivos na rede de barramento.
Tá, é porque, eu não sei porquê, mas para mim, eu fiquei até sublinhei lá, que você falou controle modular, você começou a devagar um pouco, e eu comecei assim, será que ele está indo para um controle distribuído, um controle modular? Na hora que a gente fala que está um pouco extenso o texto, é isso que a gente fala, entendeu? Você começa a devagar muito, e você induz o leitor a começar a achar coisas que não vou usar nada disso. Mas como você absorveu todo esse conhecimento, você quer falar, não, eu quero dizer, né, assim, você quer discutir um pouco isso, né? A gente sente isso.
Eu comento aí disso local, porque o que a gente implementa no controlador são os vários supervisores. Né? Então, é isso. Então, por isso eu acabo falando disso. Mas o controlador é um controlador só, onde tem todos os supervisores ali rodando junto.
Então você está usando, na verdade, um sistema centralizado em rede. Né? Então tá. Aí, deixa eu ver aqui. Então, a primeira coisa é isso. Eu vou falar uma coisa um pouco mais geral e depois eu vou um pouco mais nas páginas, tá? A outra coisa que eu achei também desse capítulo é que os algoritmos, eles estão... Você não tentou fazer, tipo assim, alguma coisa, né? Uma partezinha, tipo assim, eu quero representar a inserção. Aí eu fiz um algoritmo para isso. Depois reutilizou nos outros modelos. Você sempre repete, né? Pelo menos eu não sei, eu fiquei com a sensação, eu não conferi, fiquei com a sensação que os algoritmos têm partes que se repetem e você poderia ter criado funções e ir chamando uma função dentro da outra. E você toda hora apresenta o algoritmo inteiro. Então, eu vejo que tem partes que se repetem nas estruturas e você está repetindo sempre. Então, tipo assim, você tem, acho que 10 algoritmos, uma coisa assim, né? Uma coisa assim, bem grande, e todos eles grandes.
Esse algoritmo realmente que construiu os estimadores, eles são parecidos, porém eles estão trabalhando com eventos diferentes.
Então, mas talvez você possa criar uma função e você só chame o conjunto de eventos, entendeu? Eu estou falando assim, em termos... Até porque, assim, eu já tinha entendido, sei lá, o primeiro. Aí depois eu vi que ele se repetia. Aí, quer dizer, assim, eu não fiquei perdendo tempo porque você, como, né? Claro, como um bom aluno, está repetindo a explicação, mas você está repetindo a mesma explicação. Então, aí, no final... É por isso que eu estou falando, aí fica um pouco maçante. Tá? Então, tenta ver se você... Agora você tem que incorporar o seu poder de síntese e tentar enxugar um pouco isso daí. Não repetir tanto, né? Deixa eu ver. Então eu vou nas páginas e depois eu volto aqui para minha pergunta final aqui sobre esse capítulo. Então, eu acho que eu comecei na página 57, eu anotei aqui, deixa eu ver aqui. Aqui, capítulo 4, 5, isso. Tá bom, aqui na página 57, isso. Aí você fala com o ataque, né? Na hora que você fala que eu coloquei aqui, você fala que você insere, apaga, e com isso você também faz o replace, não é isso?
Exatamente. A gente consegue fazer
Né? Não, só para entender aqui. E eu achei... E você... Tá. Você, na verdade, fala... Então, aqui que ficou a primeira coisa. Considere que o ataque infiltra no subsistema G1. Na verdade, é M1, né? Não sei. Aí você tem que tomar cuidado, porque na sua figura do 5.1, você colocou M1, M2, M3... Ou não?
Foi mesmo. Ou não foi? Tá M1.
Isso, M1.
O M, então, o M é o nome dos
módulos.
Isso,
Dos módulos, não, do
subsistema.
Então, porque você usou M, tá vendo?
É o modelo do sistema. Entendi.
Então, aí você falou modular, usou M, aí eu falei, será que ele vai para o controle modular? Eu pensei, né, Max? Eu falei, mas então não. Então, tá. Aí você faz você insere nos eventos não controláveis. Então, eu estou entendendo que não controlável você está pensando assim na observação, não é?
Nesse caso como o sistema gera eventos não controlados, então e o IDS, como ele está monitorando a rede, ele está observando os eventos não controlados que estão sendo gerados pelo sistema. Não é isso? Basicamente, eu estou referindo na observação que o DS está vendo sobre o subsistema, sobre a ataque.
Tá, porque eu coloquei aqui não controlados. Sim, já lembrei o que é. É porque, você olha a definição. O sigma I, você falou que são as ações, né? O sigma I mais é sobre os não controláveis ou não?
Mais M é sobre todos. Porque, potencialmente, o atacante ele pode inserir na rede qualquer evento. Né? Porque, enfim, ele pode inserir um evento que é o controlado, que a princípio era um controlador que vai mandar, mas como como a rede, né? Quando uma vez que o evento está na rede, todos os dispositivos conseguem receber o evento. E não tem como esses dispositivos saberem de onde veio o evento, então o atacante pode simular, agir como se fosse outro dispositivo, como um controlador, por exemplo.
Mas aí ele não pode fazer isso também, então, para apagar?
Pois é, aí para apagar, ele vai conseguir apagar só os eventos que iam para a rede a partir do dispositivo que o atacante está infectado, que são eventos não controláveis. O dispositivo. Aí, assim, a gente assumiu isso, que o dispositivo, o professor Marques, ele faz em relação a isso, mas na maioria das aplicações que a gente viu, em caso de aplicação de termos de controle, normal de acontecer que o subsistema gera eventos não controlados. Então, como são os eventos que estão sendo gerados ali no subsistema, que vão para a rede, o atacante só consegue apagar eles, não consegue apagar eventos não controlados, porque nos subsistemas, eventos controlados estão chegando.
Mas você faz a hipótese que a gente só vai assumir, só vai ser atacado nos eventos controlados, é isso? Nos M's. Nos M's, né? Eu acho que isso daí eu lembro, cara, nos subsistemas, não é isso? Nunca no controlador.
Isso, aqui é considerando no subsistema.
Mas aí não sei. Fiquei meio assim. Teria que pensar ainda. Porque eu concordo com você. Tipo assim, você falou que você gostaria que você só apague eventos não controláveis, porque na verdade são eventos não controláveis que estejam naquele módulo. Então, você colocou isso direitinho, sigma I. Agora, a inserção Não poderia só ser daquele módulo? Porque aí, isso que eu estou falando, aí depende do que você está usando como seu canal de comunicação, né? Aí vem o diabo da implementação, né? Que você deve entender bem. Porque no canal de comunicação, normalmente vem falando da onde vem, né?
Exatamente. Exatamente. Depende da implementação. Sim, potencialmente, o atacante, se a gente não tiver, a mensagem não tiver um cabeçalho com endereço, aí tudo bem. Dá para ele simular o comportamento de qualquer outra, como se ele fosse outro dispositivo na rede.
Uhum.
Mas se tiver um endereço lá do remetente e ele não conseguir mudar isso, aí concordo com você que a gente teria que restringir aí para só ser os
Eu vou falar uma coisa que eu falei para o público. A gente fica tentando generalizar muito e acaba que não sei se você está colocando mais dúvida do que abrangência, entendeu? Porque seria muito mais natural você falar que o sigma e mais seria os eventos não controláveis, você concorda? Não, seria assim, mais...
Só os controláveis. Pois é,
não
só que só os controláveis.
Não controláveis. Não, inserção dos não controláveis. Porque já que você atacou aquele subsistema, então você conseguiria, não é isso? Inserir na rede coisas daquele subsistema. Isso seria óbvio, né? Assim, não seria nem discussão.
De não restringir esse ponto. Acaba que depois a gente acaba restringindo, né? Como fala aqui.
Então, por que você aqui já não fala logo que você só usa... Não, eu estou falando assim, não é para sua tese, não. Estou discutindo isso por conta... Porque no artigo, esses pequenos detalhes, eu estou falando isso porque a gente fez uma definição lá que abrange mais coisa, mas no final abrange opacidade, e aí todo mundo fala que o nosso trabalho é opacidade. Entendeu? Eu estou querendo dizer assim, você abrange tanto que no final acaba acontecendo mais confusão. Porque tá meio difícil você justificar que é só... Entendeu? Porque nesse caso não pode o não controlar o controlável, pode o controlável, e no outro caso não pode.
Entendi, não é.
Não sei.
Eu entendo. Porque depende dos detalhes depois da implementação.
De implementação. Aí você acaba, não sei. Não sei. Você tem que pensar aí. Mas eu só levantei essa bola porque eu achei super estranho. E se você colocar assim, você tem que fazer um comentário bem grande depois, explicando por que você quer todo o sigma aí, entendeu? Não é só os não controláveis, né? E se depois você vai restringir, aí ficou pior ainda, né?
Tá bom.
Então tá. Então aqui. Então tá. O ataque sabe tudo. Aí tudo bem. Aí na página 61. Aí eu acho que eu fiquei na dúvida, nessa tabela 5.1, exatamente aí. Você gerou o Epson, não é isso?
Isso.
Aí depois o A1, depois o B1+, que você adicionou, não é isso?
Isso.
Aí depois você adicionou o A2.
O A2. Uhum.
E aí você fez o B1-. Aí eu não entendi. Porque aconteceu o A1...
O A1 foi um evento que o controlador, né, mandou para o sistema.
Não, o que aconteceu, né? O A1 aconteceu e foi enviado, né? Vamos dizer assim. Isso, aconteceu e foi enviado.
Aí passou. Aí o atacante, ele decidiu inserir o evento B1 na rede. Simulando, falar que o controlador do evento B1 aconteceu. Então, o controlador observou esse evento. Na verdade, ele observa o B1, né? Que ele não consegue distinguir entre o B1 legítimo e o que foi inserido.
Isso.
E aí, a próxima ação do controlador vai ser inserir o evento A2.
Não, aí aconteceu o A2. Não, eu entendi isso. Aconteceu o A1, aí o B1 você inseriu, e aí aconteceu o A2. Porque aí poderia acontecer o A2, não é isso? Coisa que não poderia acontecer.
Nesse ponto não poderia acontecer, porque a planta, o M1 ainda não está no... Quer dizer, o M1, né, pensando na parte física aqui, o M1, a máquina não terminou o processo ainda.
Isso.
A operação dela.
Isso.
Aí, então, o próximo passo é o evento legítimo B1 acontecer no subsistema. E aí, para o atacante não ser revelado, porque já que o controlador ele já viu o B1, o atacante não pode deixar outro B1 ser enviado pela rede, porque senão o controlador vai ver o segundo B1 quando não deveria estar acontecendo. Então, é por isso que ele decide apagar o evento.
Tá. Eu não sei porquê, mas eu tinha sublinhado aqui. Because of the discrete-event before. Tá bom. Eu não sei porquê, mas acho que eu tinha achado estranho alguma coisa. Mas não estou achando aqui. Então, tá. Aí, você vai... Vamos para a definição 10. E eu vou, mais ou menos, depois parar por aqui, né? Porque senão o pessoal aí em Minas vai me matar, né? Estou invadindo a hora do almoço. Hora do almoço é 11h30, né, Patrícia? É 11h30, a gente já está aqui meio-dia e 15, nossa senhora. Então, eu entendi que você fez o ataque passivo. Esse delay, você tá... O que é esse delay? Isso que eu não entendi.
São essas 3 attack functions aqui.
O passivo não faz nada, não é isso? Isso.
E o delay é a attack function que vai... Quando o atacante vai usar ela quando ele quer atrasar um evento. Então, aí, como ela está definindo que sempre que acontecer um evento não controlar, a gente apaga o evento, o atacante apaga o evento, não deixa ele ir para a rede. E aí, depois que ele conseguiu apagar o evento, algum tempo depois, ele pode inserir o evento na rede, que é a última linha, que é a última condição. É claro que, como eu até disse na apresentação, aqui não tem nada impedindo, nesse ponto aqui não tem nada, assim, na verdade tem uma coisa impedindo aqui, uma das condições, mas se for, por exemplo, um evento em alto laço, o atacante pode começar, por exemplo, inserindo esse evento na rede, ao invés de apagar. Aí, realmente, tem uma parte do texto aí que eu faço essa discussão, que o atacante, ele não é, assim, só usar attack function para descrever, ele não é suficiente. Tem que ter alguma entidade, né, que vai escolher qual é a ação dele. Então, assim, se ele quer causar um atraso no processo, né, ele apaga um evento e espera algum tempo, só depois inserir esse evento, logicamente, ele tem que escolher e fazer essa ação de apagar primeiro, depois inserir. Porque se ele insere antes, ele está antecipando o evento, né? Então, é o contrário do que ele quer. Então, assim, o atacante, essa attack function, ela serve para guiar, dar as opções que o atacante pode executar, de maneira a realizar o objetivo dele, e ter um ataque persistente, um atacante persistente. Então, a ideia que é essa. Eu quero, então, né, que eu estou dizendo, toda vez que um evento não controlável acontece, eu apago ele. E aí depois eu consigo inserir ele de novo na rede.
Tá, e o 3? O que significa o 3?
Que é o forward mode? Então, aí é quando eu quero só antecipar o evento. Né? Eu quero enviar uma falsa ocorrência dele para a rede antes do evento legítimo ter acontecido. Então, a ideia aqui é que, se é um evento, né, seja controlável ou não, eu não mexo com ele, o atacante vai só repetir o evento. Agora, se for, né, nesse meio tempo, enquanto nada acontece na planta, o atacante tem a opção de fazer nada também, ou inserir um evento na rede, desde que esse evento esteja em alto laço. Tá? Porque é aquele problema, né, que eu comentei. Se não for alto laço, aí justamente aquela tabela 5.1 que a gente estava discutindo, acontece o problema que está sendo descrito lá. ele insere um evento que causa uma mudança de estado antes do evento ter sido apagado, e aí a gente quer evitar isso. Por isso eu só deixo de fazer inserções de eventos que estão em outro lado.
Tá, agora vem a pergunta que não necessariamente você precisa responder, mas vem a pergunta de revisor, né? Revisor gosta. Porque essa ideia de delay e forward tem a ver com o tempo. Mas em termos práticos, você está inserindo e apagando eventos, você concorda?
Isso.
Então, qual é a diferença de você usar, tipo, usar aquela função de inserir e a função de apagar? Do que usar essa modelagem que você está propondo?
É porque, assim, a gente tem que... O atacante, ele tem que... bom, como a gente quer que ele seja um atacante persistente, então a primeira coisa é que o comportamento dele tem que respeitar algumas regras de maneira a não ser revelado. Então, basicamente, essas attack functions que eu defini, elas vão guiar o atacante nas suas ações de maneira a respeitar aquelas instruções que a gente pôs para o atacante ser persistente.
Não, eu sei, mas eu estou falando assim, em termos... isso daí não precisa nem responder, porque isso daí tem a ver também, assim, você está falando uma nova... Eu estou falando assim, você tomar um pouquinho de cuidado com esse termo atraso e adianto, né? Porque isso tem muito relacionado com o tempo. No meu ponto de vista, o que você está fazendo, você está apagando e está inserindo. O momento que você está apagando, você está inserindo, é que está mudando um pouquinho, mas no final você está apagando e está inserindo. Não sei, eu estou só falando assim, porque a gente já fez, né, essa parte de apagar e inserir, isso daí não é nem no meu trabalho, né? Isso daí já existe, né? Então, até que ponto o que você está fazendo não é isso e você está querendo criar uma nova roupagem? Não tem problema, nada disso tem problema. Eu estou falando assim, que alguém vai te questionar, eu acho que alguém vai eu acho, né? Sobre essa sua nomenclatura e um pouco como... Porque a sua definição não está mudando nada, né? A sua definição não muda nada. Olha, porque olha bem, ó, você está pegando a sua última linha do 2 está igualzinho à sua última linha do 3, tá vendo?
Não, eu concordo que a ação em si não tem, assim, a novidade não está como a ação do atacante é feita.
Então, e você está perdendo algum tempo, assim, né, em fazer isso. Não estou falando, assim, é claro que sempre formas diferentes de fazer a mesma coisa são sempre bem-vindas. Agora, eu tenho certeza, né, que vão te questionar um pouquinho sobre isso, tá? Então, talvez não gastaria minhas fichas nessa parte.
Tá, entendi.
Tá? E aí, no final, aí veio a pergunta que eu gostaria de fazer para você. Eu entendi a sua modelagem, né? Entendi o que você fez aqui. Aí o seu ataque final, né? O seu resultado vem da figura 5.14 na página 88. Se alguém já fez essas perguntas, você me fala, porque eu não escutei muito bem, tá? Aí o seu objetivo... Não, na verdade, desculpa, é a 5.2, na página 87, né? Aí você fala, então, que se você tem que eliminar esse estado 1xe, não é isso? Não. Isso, né? Que aí são onde se revelaria que você estaria. Mas o seu objetivo inicial não era causar algum problema no sistema e não ser revelado, não é isso? Sim? E qual o problema que você está causando aí?
Então, aqui, ó, essa não exposed, quer dizer, aqui ainda está com o estado que revela, né?
É isso, aí pode ir para outra página.
Então,
tudo bem.
Aqui a gente tirou esse estado. Isso. Então, aqui, o que a gente está mostrando aqui? Que tem diferentes ações que o atacante pode fazer.
Então, isso.
Então, por exemplo, aqui, nesse exemplo, né, que tem um evento A incontrolável, então o atacante não pode fazer nada com o evento A. Mas uma vez que o evento A aconteceu, o próximo evento aqui é o evento C, que vai estar em alto laço aqui. Quer dizer,
Isso.
então, assim, ele tem, a partir desse ponto, ele tem 3 opções aqui, por exemplo, né? Ele pode escolher fazer nada com o evento C, esperar o evento C acontecer normalmente, né, e deixar ele passar sem problema, ser enviado para a rede. O atacante pode escolher apagar o evento C quando ele acontecer, que aí é representado pelo C-M. O atacante pode também, em algum ponto, né, normalmente antes do evento C acontecer, ou mesmo depois, né, que ele está em alto laço, ele pode inserir o evento C para a rede. Então, ele está antecipando o evento. Então, dependendo da ação que ele está causando aqui, que ele vai usar aqui, né, ele vai fazer um delay do evento, porque aqui, por exemplo, se ele escolheu apagar o evento, depois, o que ele pode fazer? Ele pode inserir o evento para a rede, ou ele pode continuar apagando o evento, como ele está em alto laço, ele pode continuar apagando, ele pode escolher inserir o evento. Então, teve um delay em relação ao evento C, em relação ao que o supervisor, o controlador viu, desde o ponto em que o evento C ocorreu legitimamente e até o momento que o controlador recebeu o evento C. Então, esse é o delay. Então, tá vendo? Esse caminho de cima é o delay. O caminho de baixo, quando o atacante decide inserir o evento C antes de ele acontecer, é o caminho quando o atacante está escolhendo antecipar o evento. Então, ele vem para cá. Então, assim, aqui mostra as opções, né, que o atacante... Agora, se o atacante não decidir fazer nada, ele fica só entre esses dois estados, o 1 e o 2. Não sei se eu consegui responder a sua dúvida, mas...
eu entendi. Você, na verdade, você está... É porque esse atraso, né, eu entendo também por conta do... Ele não causa nada, né? Assim, não causa nenhum dano para
exatamente, não causa, exatamente, são ataques sutis.
É isso que eu
Ele vai causar um dano
aqui
no produto depois, ou...
Qual é o objetivo do atacante? Porque só inserir atraso sem você analisar o tempo está meio difícil de ver, né? Qual é o objetivo.
Sim, exatamente. Aqui a gente não está dando foco no tempo ainda, mas vai ser a gente vai usar essa mesma modelagem e começar a olhar para o tempo para poder especificar completamente como é que o atacante vai...
ou você traz um exemplo que isso interfere em alguma coisa, né? Que aconteça... que não seja só o C. Eu entendo que você colocou só o C por conta de um problema de espaço, mas que possa atingir alguma coisa, um estado ruim, né? Para justificar um pouco mais o seu... Porque você está falando que você tem 2 objetivos, né? Porque senão você vira o stealthy, né? Ele só fica escondido.
De certa forma, ele é stealthy, assim, claro. Tem bastante consideração para ser feita, né? Porque ele pode, do ponto de vista do IDS, ele pode ficar stealthy, fazendo tanta coisa, mas, como eu comentei também na apresentação, eu assumo que o atacante sabe que o impacto das ações dele vão causar no tempo. Então, ele pode ficar stealthy do ponto de vista do IDS, mas causar 2 máquinas funcionar ao mesmo tempo, enfim, que vai uma colidir com a outra, causar um tanque, fazer um tanque ter um overflow dele, enfim. Então, assim, a gente o atacante tem que saber que ele vai causar no sistema, assim.
Entendi. Não, então, é isso que eu tô tipo assim, porque pelo seu exemplo, não deu muito para ver isso, entendeu? Só deu para perceber que ele realmente, ele precisa se esconder, então você precisa realmente de uma parte de um supervisor, mas em termos de causar prejuízo no sistema, eu não, entendeu? Tirar e colocar evento não ficou muito assim.
Entendi.
Nesse exemplo não ficou evidente a vantagem disso.
Um exemplo mais detalhe, né? incluindo a questão do tempo no exemplo, acho que entender melhor. Né?
Não sei se na sua implementação você fez isso.
Na implementação, você tem que... a implementação ainda tem... Sim, você consegue implementar a questão do tempo lá, só que do jeito que o IDS ainda... A gente não tem uma Chagas ainda implementada lá, então esse atacante pode passar percebidos de ajudamento dos eventos.
Tá. E só tirando uma última dúvida aqui, você implementou essa rede CAN aqui, como? Vocês compraram módulozinhos de rede CAN? São redes físicas? Oi.
Perdão, eu cortou um pouco.
Eu imagino, não, claro. Aqui, só no último capítulo, só a última dúvida aqui, que já são meio de meia. Essa rede CAN, você comprou uns módulos em Arduino, que você comprou os módulos de comunicação?
Isso, eu comprei os módulos, porque eu até pesquisei, assim, o Arduino, ele tem algumas capacidades de comunicação, e o time dele lá de comunicação com protocolo CAN, só que na época eu analisei e vi que não era tão vantajoso, porque tem questão de compatibilidade de extensão, enfim. E aí eu tentei e usei, como era de fácil acesso a módulo, a gente colocou módulos de comunicação CAN associado com o Arduino.
Tá. E aí você consegue as mesmas faixas que se fala assim no protocolo ou não? Se fosse implementado em PLC? Ou você não fez essa comparação?
É uma boa pergunta. Eu não confesso, eu não avaliei essa questão. Tem que investigar isso. Tira algumas velocidades. Porque, assim, a princípio, como a gente fez um sistema simples, né, assim, eu planejo um pouco mais na parte, né, de desenvolver a aplicação, do dispositivo, mas realmente os detalhes com relação, por exemplo, à velocidade da comunicação, eu não cheguei a olhar com muita atenção ainda. Então, não vou conseguir te responder isso agora.
Tá, não, só porque eu tô precisando de um negócio para testar aqui meus algoritmos. E aí eu estava cuidando que o aluno que estava testando foi embora, e aí a gente ficou na mão aqui. Mas tá bom, muito obrigada de novo, Michel. Agradeço mais uma vez o convite.
Entendi.
E eu vou encerrar aqui, até porque a internet já está, né? Emperrando aqui. Obrigada.
Obrigada, Lívia, pelas suas considerações. Eu vou passar a palavra para o Rodrigo para fazer as considerações dele.
Okay. First of all, I would like to thank Michel, Patricia, and Karen for the invitation. Are you hearing me?
Yeah, we are here.
Yes.
For me, it's an honor to be a member of this committee. So I don't have too many questions, just concerning the the first question is about the assumption, Michel, about the assumption to ensure that somehow you are
Just for the question, please. Because the internet is all here.
Então, Michel, minha dúvida é o seguinte: você garante, de certa forma, uma robustez, né? Se se as assumptions forem verificadas, você tem condições que garantem robustez contra, né, os ataques, né? Não é isso? E aí a sua hipótese... Isso, né? Não é isso? Assim, quer dizer, que você não fez o projeto controlador para garantir a robustez, ou seja, o sistema está todo projetado, você está fazendo análise, né, do sistema. A sua hipótese é que o atacante só pode atuar no conjunto dos eventos não controláveis, não é isso? Só confirma para mim.
Então, exatamente. Nesse trabalho, a gente baseou, né, o ataque. Essa parte de um modelo de ataque que já estava proposto em outro trabalho. Lá, eles consideram que o ataque acontece no canal de comunicação do supervisor. Então, como, né, pelo entendimento que a gente tem, né, do sistema de implementação, sabe que os eventos que estão sendo enviados na geração, enviados para o supervisor, são eventos não controláveis. Então, a gente... agora, eu nem lembro, não consegui lembrar esse artigo, né, que a gente baseou de ataque, eles falavam isso explicitamente, mas a gente considerou que eventos, como está no canal de comunicação da planta do supervisor, são eventos não controlados que o atacante pode agir sobre.
Sim. Aí vem a questão, né? Mas o atacante ele não tem como distinguir os eventos, assim, em princípio, concorda? Como que ele vai saber que ele não... ou seja, então tem mais hipótese, ele assume... É isso que eu queria saber, assim, em termos das hipóteses.
Tem mais hipóteses. Tem mais. Por exemplo, a gente assume que o atacante, ele sabe, conhece o sistema, assim, os modelos. Isso. Não é uma coisa assim tão irrealística, porque quando a gente lê os casos de ataques, muitas vezes o atacante realmente é alguém que está, ou ele fica observando o sistema para aprender, ou é alguém de dentro, né, que faz o ataque, então ele realmente tem conhecimento do modelo. Então, uma coisa que a gente está assumindo é isso, que o atacante sabe, ele sabe sim quais são os eventos controláveis. Mas tem outro detalhe, controláveis e não controláveis. E tem um outro detalhe que esse modelo de ataque do capítulo 4, como o ataque acontece no canal de comunicação da planta para o supervisor, então todos os eventos que passam ali são não controláveis. Você consegue atuar nos eventos não controláveis.
Sim, aí no exemplo lá o exemplo 8 ficou claro, né, o efeito.